Hi everyone, so welcome on YourPedia education platform, and as you know, on YourPedia we are covering the important NPTEL assignments, and these assignments are very important. The concepts in these are very good, and these assignments are prepared by so learned professors of IIT, and these questions will also be very relevant for your upcoming exams. So this lecture is related to two such questions based upon very good concept from mechanical vibration. And before I solve these questions, let me tell you that the questions whatever we do here and their solution are available for download on our website YourPedia.in. If you go on our website YourPedia.in, there is a drop down downloading menu. This on the menu bar you will find drop down download this particular folder, and in that folder in the download you will find NPTEL assignments, the topics which we cover. The document is also available there. You can take that particular document for all the topics. So whatever mentors are covering, whatever topics they are covering, you need not to write here, that is available there. Okay, so let's start now, and I go for this question. I want you to first read this question. Very good question from again NPTEL assignment. It is related to potential energy of the particle of mass 0.1 kg, and it is moving along x-axis, and the potential energy in joule is given as a function of displacement, that is x. So x is not a displacement, it is basically the particle is moving along x-axis. So x is given in meters, energy is given in joule, and he is giving you a couple of options. So he says which of the option is wrong. So is speed of particle maximum at 2, does it execute a simple harmonic motion, period of oscillation of the particle is pi divided by 5 seconds, particle does not execute simple harmonic motion. So these are the questions given. So before I solve this question, let me tell you a couple of concepts here. Let me take you to some concepts. So we know simple harmonic motion, SHM. So let me erase it. Okay, so SHM or simple harmonic motion, what we know is simple harmonic motion, the concept is acceleration is proportional to negative of displacement. That concept is there in simple harmonic motion, that acceleration is proportional to minus displacement. Second is at equilibrium, at the position of equilibrium, if we see at the equilibrium, what we get is potential energy is minimum. This is the another concept which you should know. At equilibrium we get minimum potential energy, because whenever body is displaying the simple harmonic motion, it reaches the equilibrium, and at the equilibrium we get minimum potential energy, maximum kinetic energy. So velocity is maximum at the mean position, and equilibrium is obtained at the mean position. That is the another thing you should understand. So at the mean position, potential energy is minimum, kinetic energy is maximum, so velocity is maximum, and there is a relation between the force acting on the body, because if there is acceleration, obviously there is a restoring force. Minus x means x is a displacement from the mean position. So when the acceleration is negative, proportional to negative of displacement, that means the body will restore or come back to the mean position. So as the body moves away from the mean position, as it has x, the negative x means there will be force acting on the body towards the mean position. So body will be coming back to the mean position. So there is a restoring force acting on the body. That is the meaning of acceleration proportional to minus x. Now A is proportional to minus x means body is coming back to the mean position, and simple harmonic motion will be displayed. Now this if I say the kinetic energy given is u, then du by dx, that means differentiation of u with respect to x is leading you to the force. That means it will be related somewhere to the force, and I can link this potential energy with the force applied on the particular body. So I can link it with the force, and force is equal to minus du by dx. So the force acting on the body is equal to minus of differentiation of du by dx. Now I want to find out where is the potential energy maximum and minimum. So all I need to do is I need to find out du by dx. So what is u given to us? U is 5x square minus 20x. That is the value. So if I open the bracket, I get this 5x square minus 20 of x. Now du by dx is equal to 0. If I make it 0, what I get is 10x minus 20 is equal to 0. That means x minus 2 is equal to 0. That means x is equal to 2. So at x is equal to 2, differentiation of potential energy is 0. And either the potential energy is maximum or minimum. Du by dx 0 means either u is maximum or minimum, you know that. But how do we know it is maximum or minimum? So you can go one step forward. So if you go one step forward, du square by dx square, just find it out what is the value coming. It is coming out to be 10 and it is positive. So when double differentiation of u is coming positive, that means the u which we are getting is negative. The u which we are getting is minimum. Had it become negative, suppose it would have come negative, then the u is maximum. So first you differentiate potential energy with respect to x, make it 0. That at that point either u is maximum or minimum. Then you double differentiate it. If double differentiation comes positive, then u is minimum. So that means now we are sure this u is minimum, and the minimum value of u can be obtained at x. And what we know is at the mean position u is minimum. At the mean position potential energy is minimum. When potential energy is minimum at the that is the mean position we have got. Now let's find out whether it is a simple harmonic motion or not. Now we know that f is equal to minus of du by dx, right? And du by dx here is now minus 10x plus 20. That is what we are going to get it, right? And f is is equal to nothing but m into acceleration. So that means m is how much given? M is given as 0.1, 0.1 into a. That means a is coming out to be somewhere 10 times minus 10x plus 20. And as you can see clearly here that a is coming out to be minus x, proportional to minus x. That shows it is a simple harmonic motion. We discussed that what is a simple harmonic motion, that a should be proportional to minus of x, and it is coming in this particular case because we can write this as another variable, capital X or something. So that means it is coming proportional to minus of value x. As x increases, acceleration also increases, but in the negative sense. That is the meaning of it. Now we need to find out the speed of the particle is maximum at x is equal to 0. How can we say? Now see these choices. Is the speed of particle maximum at x is equal to 2? Yes, x is equal to 2 is the mean position, and mean position means kinetic energy is maximum. Kinetic energy is maximum is velocity is also maximum, speed is also maximum. That is correct. Particle is executing simple harmonic motion. That is also correct. So if particle is executing, this D choice is the answer for this question. Why? Because this D choice is in contradiction with B choice. So if B is correct, D has to be incorrect. But let's see how to find out the time of oscillation. Now we also know that acceleration is equal to minus omega square into x. That is what we know, minus omega square into x. But I tell you, this actually is minus omega square into x minus x naught. This is very important. Now what is this x naught? X naught is the initial position. So the formula that acceleration is proportional to x, in this case x is the displacement from mean position. This is x is displacement from mean position. So from mean position, how far is the body? That is the value of x. So acceleration is proportional to minus x. What is x in that? Displacement from the mean position. But body is not sitting at mean position. It is body, actually x is equal to 0 is not the mean position. X naught is the position of mean. So we got that x is equal to 0. The body is at mean position when x is equal to 0. So if the body has gone away from mean position, that means it has gone away from point 2. See this carefully. Suppose I am saying this is the x-axis, this is 0, this is 2, and let us say this is the mean position. Let us say this is the mean position. X is equal to 2 is the mean position. Now suppose body goes away from mean position some distance. How much is this distance? This distance will be x minus 2, because 2 point is already there. So acceleration is proportional to minus x. Actually it is, acceleration is proportional to minus x minus x naught, that is the initial position, and constant of proportionality is omega square. So actual general formula of acceleration is equal to minus omega square x minus x naught. This question is basically based upon that particular concept. So x naught is how much? X naught is equal to 2. So let's put it now, this formula and this formula we have, now this formula also. Yes, this is acceleration, this is the formula we have got. So minus omega square x minus 2 is equal to 10 into minus 10x. So I take this 10 also common, so minus 10 also is taken common. This is x minus 2. X minus 2 gets cancelled out, and omega square comes out to be 100. So omega comes out to be 10. Omega is nothing but 2 pi by t. So t, the time period, comes out to be pi by 5. So that also is a correct statement. So incorrect statement is only D. So through this question, I think there are a couple of concepts you should build up, and I am expecting this question in exam, where he will give you potential energy, and you need to understand that acceleration is proportional to minus of the displacement from the mean position. So now mean position is at some particular point, x is equal to 2. So the displacement from the mean position is x minus 2. That is another concept. And then how the potential energy is related to force acting on the body, that particular part also you should know, and the time period thing also you should know. I'm sure you have understood this particular question. So if you have understood this question, read this question and try to tell me how you will answer this question. This is another good question. And as I told you, I have already provided you the solution for these questions. You can download the solution, you need not to write, you can download. So he has given you potential energy. Now see, this is a cubic function. Potential energy is a cubic function. 2x cube minus 9x square plus 12x. And body of mass 1.5 kg is moving along x-axis. Potential energy is given in this. And you have to tell, where will be the equilibrium, where equilibrium, stable equilibrium, that is the point at which potential energy will be minimum. And when it is displaced slightly from the equilibrium position, it executes simple harmonic motion. You have to find out what is the position x naught. Okay, let's see. So we are given this u as now 2x cube minus 9x square plus 12x. What is force? So force is minus du by dx. That means minus of 6x square minus 18x plus 12. So I can write it as minus sign of, if I take 6 common, if I take this 6 thing as common, then I can take this particular thing common. So for me, minus 6 I can take common. What comes is x square. So if I take 6 common, it comes x square minus this is, okay, so x square minus 3x plus 2. So this further can be written as x minus 2, x minus 1. So minus 6 comes out, x minus 2, x minus 1. There is a differentiation. Now if du by dx is 0, if I put du by dx to be equal to 0, either I get x is equal to 1 or I get x is equal to 2. But at which point you get u minimum and maximum? And as you can see in this diagram, at particular value of x, u is coming to be maximum, and particular value it is coming minimum. Looks like this is 2, looks like this is 1. From the graph also you can see x is equal to 1 by u is coming maximum, and x is equal to 2 by it is looking like coming minimum. And if I ask you one thing, see this graph carefully and tell me, where do you think the body will come back to its mean position? Can you see this? This is the only point where body may oscillate about the mean position. So this looks like the mean position. Let's go mathematically. Du square over dx square. Let's find that. Du square dx square, what is that coming? Du square dx square is coming, I again differentiate, 12x, okay, minus 18, 12x minus 18, okay, looks like this. So let me take now 6 common, this is 2x minus 3, this is the differentiation. Now let me see if I put x is equal to 1, at x is equal to 1, what is the d square u by dx square coming? That is coming out to be, now x is equal to 1 by 2 minus 1, it is coming out to be minus 6. Okay, at x is equal to 2, what is du square over dx square coming? Okay, it is coming out to be 4 minus 6, this is coming 6. So here u is maximum and here u is minimum. So x is equal to 2 pi, u is coming out to be, you know, minimum, and at x is equal to 1, it is coming out to be maximum. But what is the minimum or maximum value of u? Suppose what is the, he ask you what can be the maximum value of the potential energy. Let us say what can be the maximum value of potential energy. So maximum value of potential energy can be obtained at x is equal to 1. So u max, what is the maximum value of potential energy? Put x is equal to 1 here. This is 2 minus 9 plus 12. How much we are getting? This is 5 joule is the maximum potential energy which we are going to get at x is equal to 1. So sometime he might ask you what can be the maximum potential energy. So how do we get minimum or maximum potential energy? Potential energy is given to us, differentiate it with respect to x, equate it to 0. You will get maybe 2 values. If you get 2 values, at one point it can be minimum and another can be maximum. So again differentiate, and if you get negative value it is maximum, if you get positive value it is minimum. So we got these two things. Now our question is related to simple harmonic motion. Now it is going to display simple harmonic motion somewhere here. Now what is the answer for us? Let's go here. For simple harmonic motion, now to display simple harmonic motion, f is equal to minus du by dx. What is that? Minus du by dx is 6x square minus 18x plus 12. So as I told you, take 6 also common, what you get is x minus 2 into x minus 1. That is the value of f, but f is nothing but that is also m into acceleration. Now we know acceleration is nothing but it is minus omega square x minus x naught. But how do we get what is x naught? What is the mean position? We have already got what is x naught. X naught is value of equal to 2 because we are getting mean position at 2. So he wanted you to calculate what is the x naught. X naught is nothing but that is the value of is 2, but we can find out what is the time period of oscillation also. Now do we display the simple harmonic motion? Let's try to see this. So omega square x minus 2 is equal to 6 into x minus 2 into x minus 1. So from here you can get, so if you see this is MA, if you see carefully, A comes out to be minus of 6 into x minus 2 into x minus 1 over M. So looks like if you differentiate, see this, looks like it is the body is coming back to the mean position. So if you see that way, this looks like a simple harmonic motion at x is equal to 2. So at that particular point, limiting point, it is going to display simple harmonic motion. Now if you cancel it out, you get omega square is equal to 6 into x minus 1. Now it is displaying the simple harmonic motion not in the entire range of value of x. It is displaying the simple harmonic motion only at about point 2, x is equal to 2. So we need to put at point 2, and if we give at point 2, it comes out to be approximately 6, but yes, m is also to be divided. I don't know where m has gone. M, this is m into a, this is the force, and m into this. So this is divided by m. M is nothing but given as 1.5. So 6, 1.5, this is coming out to be 4. So omega comes out to be 2, and that is nothing but 2 pi by t. So what is the value of t in this case is a pi second. So in the previous question, we found out the value of t. In this question also we are finding the value of t. This is a typical good question for exam like GATE exam for you. Why? Because he is going to ask you what is the time period of oscillation, and many students will get confused here, thinking that okay, this omega square is coming as a function of x now, what to do? But you need to find that this body is oscillating about the mean position, and mean position is obtained at value of x is equal to 2. So you need to find out the value of omega at that particular value of x. You need to be at that particular point, and hence you can find out the time period of oscillation using this. I am very sure these two questions you have understood. If potential energy is given in mechanical vibration questions, how you have to find out the time period of oscillation, and how you have to find out the potential energy values, and maybe certain more things which he will ask you on the basis of this, like velocities and all. So mechanical vibration, potential energy, and the concept related to that is important. Just go there revising these concepts, and these two questions along with the theory please download from our website. Thank you.